Okay, finding the electric field on a small charge. I've given you the charge value and you're given the distance. Electric field is that weird kind of quantity, um, capital E equals KQ over R squared. I'll always, when I'm handwriting it, put the little vector hat above the E to emphasize that it is a vector, and that also helps us keep it from getting confused with energy. So the first step is just kind of a plug and chug. The K is a constant for electric fields. It's always 9 times 10 to the 9. For this first one, I'm going to put in the units, newtons meters squared per coulomb squared. It's got kind of a funny unit. Then we need to multiply that by the charge. For this example, the charge I made up was 2.5 times 10 to the negative 6. That's in coulombs. And then divide all of that by the distance. The distance has to be in meters, so this becomes 0.15 for this question. And then square that. Grab your calculator and crank that out. Capital E with the vector hat, nice clean numbers. It's going to work out to exactly 1 million. You can double check that. If you follow through on the units, this coulomb cancels with one of those. This makes a meter squared, and those two cancel with that. So we get these funny units of newtons per coulomb. It's kind of like the 9.8 number, but 9.8 was gravity. It was newtons per kilogram. Since this one's electric field, it's going to be newtons per coulomb since it's electricity. The last step is, because it's a vector, I need to think about the direction. It says that it's a small ball and that it's positive. For electric field, we always imagine what the charge would do to another positive. If we put a positive near this thing, it would be repelled away. So the electric field has got the value of 1 million, the units of newtons per coulomb, and it's away from the charge since this particular charge happened to be positive.